Okay, here we are going to prove the log laws. The first two log laws, they're just by definition the inverse, so there's no proof necessary. So we're going to prove the third one here. So the third one is the product to a sum law. Okay, so what we're going to do first, we're going to do a little trick here. We're going to let x equal a to the m and y equal a to the n. Okay, so we're doing this for convenience. You wouldn't be expected to figure this out on your own, but hopefully you can follow. So if x equals a to the m, then if you convert this to a log, that would mean that m equals log base a of x. Okay, so this should be standard by now to know that. So to convert an exponential to a log, you're going to have the exponent equals log with this base of this side. Okay, it's kind of like having, if you had x squared equals something over here, then x equals the square root of this thing. Okay, so because of these, we have these statements, which is what I just said. Okay, they're the inverse statements. Okay. Now, if I multiply x times y, so x times y, I'm going to use this expression and this expression. So it's a to the m times a to the n. Okay, x times y. When we multiply with the same base, we just add the exponents. And now, if you want to prove this, we're going to start with the left side. Okay, so the left side is log of base a of x times y. And I'm just going to sub in what x times y is. So x times y is this, which is this. Okay, so log of x times y is going to be log of that because they are equal. Now, because they have the same base, log base a of a to the something, okay, so this was our first law, we can just write it as m plus n. Okay. And now we know what m and n are. M is this, and n is this, so we just fill them in. And now we have the law. Okay, so log base a of x y equals log base a of x plus log base a of y. Okay, so it equals the right side, and there's our law. Now, proof of the second one, or the next one, proof of 4, which is this law, the division law to subtraction. We're going to do a similar thing. We're going to do the same let statements. Okay, so let x equals a to the m, y equals a to the n. Then m equals log base a of x, n equals log base a of y, same thing. And then when we go left side here, so left side of this equation equals this. Okay, so x over y. X is a to the m, y is a to the n. And when we divide exponents with the same base, powers with the same base, we subtract the exponents. And now because we have the same base here, we're going to use the first law again, and it just gives us m minus n. M is this, and n is this, and now we have the law. Okay, so that is the division to subtraction law. All right, the next one is going to be the power one. Okay, so we've got the power law. So what we're doing here is we're going to drop this power down in front, and we get this. We've got to prove this. We're going to do the same thing then. Very similar. Let x equals a to the m. We don't need to go much further than that one. We don't need a y in this one. Then x to the r, okay, because we have an x to the r in here, is going to be a to the m to the r. And when we have a power of a power, we just multiply these exponents. So it's a to the r m. Now, left side. Okay, so and also we have, because of this, we have m equals log base a of x. Okay, the inverse of that. Okay, so the left side, we're going to sub in x to the r here. Okay, so x to the r is a to the m to the r. We know that's a to the rm, which is what we have here. And now because of the same base, we're going to get rid of this part using the first law that we had, and we get Rm. And because we know that m is log base a of x, we're just filling that in, and now we're proving that law. Okay, so the right side, there's the law. Okay, the next one is the change of base law. So proving this one a little bit different, not too bad though. So I'm going to prove this law here. Again, we're going to let x equal to a to the m, then m equals log base a of x. Okay. And now I'm going to apply log base b to both sides of this. Okay, so I'm going to log base b of this side and log base b of this side. When I do that, I can bring this exponent down. M comes down in front. Okay, and once I bring that exponent down, I can then solve for m. Okay. M equals this, log base b of x over log base b of a, which is this right side of this, and m is log base a of x, based on what we let x equal. So put it in there, and now we have the change of base law. Okay, so I'm going to show you a couple more examples using these laws. Okay. All right, so log base 25 of 5 to the 3. Well, they're not the same base, but we can do something to make it that way, because 5 is the square root of 25, so we just substitute that in. And square root can be written as an exponent, okay, and we can bring that 3 down. So that 3 can come down in front, and the 25 can be written as, root 25 can be written as 25 to the 1/2. Okay, and right from here, these are the same, so you could replace it with just 1/2, and you get 3 halves. Or you could bring the 1/2 down, and you've got this part, and you're at 3 halves. Either way, evaluates that. Okay, something like this. If you want to express this with just an x and a y separately, so you could do the product to a sum, and then you could use the power law to bring those exponents down, and we've got this. Okay, so that's another way to write this expression. Here's another one, log base 6 of 6 root 6. Well, we don't have 6 as the base here alone at the moment. We can change that to 6 to the 1, which is that one, and 6 to the 1/2, which is root 6. And product of powers of the same base, we add the exponents, so that becomes 6 to the 3 halves. Now these cancel each other out, and you've got 3 halves. Okay. And here's a little more complicated one, log base b of the root of this expression. Well, the root means exponent 1/2, so you can replace that. And then you can use our power law and bring the 1/2 down. Okay, so we bring the 1/2 down. Now we can break this up into a sum of 3 things using the product to a sum rule. Okay, so sum of this, this, and the last one. And then for each of these, I can bring this exponent down. There's no exponent here, so I'll just leave it, and the 3 can come down. And then I can multiply the 1/2 in, and I've got this long expression here. So this is another way to write this expression. Okay? And that's it for this video.